All right, so for the warm-up, what we're going to do is we're going to take these two ions and we're going to write the chemical reaction for them. Okay, so we're going to start with Mn4 plus. So this is our first reactant, so starting chemical. And then we're going to combine it with O2 minus. So what we're trying to figure out today is to figure out what compound they make and then how many of each we need in order to finish up this reaction. Okay. All right, so if you guys remember, what we want to do is we want to balance the positive and the negative energy, right? So if we take a look at these two ions, you guys will notice that Mn is +4 and oxygen is -2. God bless you. Okay, so hopefully you guys notice that we're going to need 2 of these oxygens to balance out 1 of the Mns, because Mn is +4, oxygen is -2, so we need 2 oxygens to get to -4 to balance this out. Okay. All right, so the compound that we're going to make one new molecule. And the molecule that we make is made up of 1 Mn, and it's made out of 2 oxygen. So we put it like that, okay? So if we kind of visualize it, that means that we need 1 Mn. I'll make a red circle for that. And it has to be balanced out by 2 oxygens. And the chemical that they make is basically Mn with 2 oxygens attached to it. Okay, so we have one of these structures. Okay, so if you guys notice, all the stuff we've been doing for these ions, we've been looking at these ions that are made out of only one element, right? So we go on the periodic table, we look at one element, and we look at whether it's positive or negative, okay? Today, though, we're going to be looking at something called polyatomic ions, okay? So I do want you guys to write down the term polyatomic ions. Just have it written down somewhere on your paper. But polyatomic ions are molecules that have a charge. So write that definition down. And again, if you guys are logging into Canvas, try to have this screen up, because I'll be talking about this chart right now, and it'll be very helpful as we do our practice problems together. Okay, so like I just said, up till now, we've been looking at ions that are just one element. Just go to the periodic table. We look at if it's positive or negative. However, now we're going to be looking at these things called polyatomic ions. And these are groups of elements, so molecules that stay together. These guys don't break up. But when you put them in a group together, they have positive and negative energy. Okay? Okay, so that's polyatomic ions, molecules that have a charge. All right, so if you guys take a look at this chart right here, we have the ones that we're going to be using for this class. So if you guys notice, they're a little bit different than the ions we've been looking at, because all the ions we've been looking at are just one element, right? So for example, we have like Mg, and that's 2 plus. But if you look here, we have this group of atoms, right? We have NH4, and when you put them together, this whole thing is going to have a positive charge. Or if you put these guys all together, they're going to have a negative charge. Okay? I know that looks a little complicated, but they're actually really easy to work with. What I want you guys to remember is that you never break these up. So I want you guys on your definition next to here, I want you guys to write down, copy exactly. Okay? So copy exactly. You don't change anything about these. You don't split them up. You don't change the numbers. You don't do anything. You want to copy exactly what's right on this chart, okay? You guys do not need to memorize this. You will have it available to you for all your assignments. We're going to do a lab on this and your exam. You'll have this available to you, so you don't need to memorize it, but just know that you need to copy this exactly the way that they are, okay? But they pretty much function the way that regular ions do. So we're going to do some practice problems right now just to show you guys. Again, have this up on your screen if you guys have it on Canvas, just because it'll be easier for you guys to refer back to this, okay? All right, so we're going to do balance equations, same thing that we did last time, same thing we did for the warm-up, but this time we're going to be doing it for these polyatomic ions, okay? So we're going to write the balance equation between these two ions. So let's start with number 1. So on your paper, I want you guys to write this down. Ca2 plus and nitrate. Okay, so just write that down on your paper. Number 1, we are going to be combining Ca2 plus and nitrate. All right, so hopefully you guys can identify very easily that our cation, the positive ion, is just Ca2 plus. Okay, we're going to be combining that with nitrate. Now, nitrate is not on the periodic table. It's one of the new polyatomic ions that's in the chart that we just talked about. So I want you guys, if you have the chart available on the screen for you, I want you guys to scroll up and I want you guys to just write down the chemical formula for nitrate. I'm going to pull it up on my screen in a sec, but I know people are copying this down. But if you guys have the chart available, I want you guys to just write down next to the plus sign the chemical formula for nitrate. And again, copy it exactly the way it's written on the chart, okay? Okay, so if you guys take a look at nitrate, hopefully you guys see that it's NO3 minus right here. So we're going to copy it exactly the way that it is written on the chart. So here we're going to write Ca2 plus is combining with NO3 minus. This is nitrate, okay? And again, I didn't change anything about it. You keep it exactly in the same order that it's there, okay? Now, what we're going to do is we're going to look at the positive and negative energy. Hopefully you guys identify that this is positive 2 and this is negative 1, right? So that means in order to balance this out, we're going to need 2 of these nitrates in order to balance out 1 of the CAs. Okay. So Ca is positive 2, NO3 is negative 1, so we need 1 Ca and 2 NO3s. Okay. And if you guys notice, it's the exact same thing we did for the warm-up. We're just balancing out the positive and negative energy. The only difference is this nitrate is a little bit bigger than the ions that we've been looking at. Okay. All right, now let's talk about the product side, the side with the chemical we're going to make. We're going to make 1 of the chemical, so it's always going to be 1 for this unit. And what we're going to do is we're just going to first copy down these 2 next to each other, okay? So we're going to write Ca, and it's going to be combining with NO3. So let's just start by putting them next to each other, okay? All right, now, we only need 1 Ca, so we can just leave that by itself, but we need 2 of these nitrates, right? Unfortunately, we can't just put a 2 right here because then it looks like we have 32 oxygens, right? So instead, what we're going to do is we're going to put this entire thing, the polyatomic, in parentheses, and then we put a 2 behind it, okay? And that's it. If we need multiple of a polyatomic, you just put it in parentheses, and you put however many you need right behind it. But if you guys notice, this NO3 section, nitrate, this thing stays exactly the way it is. We don't change up anything about this formula right here. We just copy it exactly the way it is. We just put it in parentheses and put a 2 behind it. All right, any questions on that first one? Hopefully it's not too bad. Again, it's the same thing. Just balance out the positive and negative energy. And then if you need multiple of this polyatomic, the new thing we just talked about, just put parentheses around it. All right, let me give you guys about 3 minutes. See if you guys can try number 2. Number 2 as they're both polyatomic, so you'll have to look at that chart. See if you guys can write down ammonium and phosphate and see if you guys can finish up the equation, okay? Again, if you need multiple of a polyatomic, just put parentheses around it when you put it together, okay? And then we'll go over the answer in about 2-3 minutes. Okay, so first thing you should notice is that we have 2 polyatomics. We got ammonium and phosphate. So I have the formulas up there for you guys, but very easy to find this. You just go to the chart. You look for ammonium, NH4+. You look for phosphate, which is right here, PO4 3-. So again, You want to copy it exactly the way it's written on the chart, which is why I got this right here. Any questions about copying down the ions? Hopefully that part's easy. Okay, now we're going to write the chemical equation, so we're going to add them together. Now, if you guys notice, we have +1 and -3. So it should be fairly obvious. We need 3 of the ammoniums because it's +1 to balance out 1 of the phosphates. +1, -3. So you need 3 of this to balance out this guy right there. Okay. All right, so we draw our arrow, and we're going to make one molecule. Okay, and again, the easiest way to do this, yeah, what's up? That's phosphite. Yeah, if you go up, yeah, the names are a little bit similar. Phosphate is PO4 3-. Phosphite is PO3 3-. Yeah. If you wrote phosphite, but did everything else correctly, you're fine. The names are a little confusing. You'll get used to it as we do this more. But good question. All right, so the easiest way to do this, again, is just write down the ions next to each other. So write down NH4 and write down PO4. Okay, haven't changed anything yet. Just write them down next to each other. And then if you guys notice, we need 3 of the ammoniums, right? So we're just going to put the ammonium in parentheses and put a 3 behind it. And that's it. You guys got that? Easy peasy. So if you ever type this, if you type this into your computer, it would be parentheses NH4, parentheses 3, and then PO4. Again, all you have to do is put them next to each other, and you're good. Alrighty, any questions, guys? Hopefully not too bad. Okay. Okay, so hopefully it's not too bad writing this equation, but now I'm going to show you how to reverse engineer it. So we're going to take a look at these 2 compounds. Okay, so let's start with number 3. Okay, so on your paper, I want you guys to copy this down. Okay, because this time, instead of having you guys write the equation from the front end and then figuring out what you make, we're going to be going backwards. Okay, this chemical right here is what we are making. So this is on the right side of the arrow. Okay. And what we're going to do is we're going to figure out what it's made out of, but it's pretty simple. We just go kind of backwards. All right, guys. So we have Sb and then parentheses NO3 3. Okay, so we're going to go to our polyatomic chart and look for NO3. Okay, so let's go to the chart. NO3 is nitrate, and if you guys notice, it's -1. Okay, so on our paper, we're just going to write down that this chemical right here, it has nitrate, which is NO3 -1, and it looks like there's 3 of them, right? Because it's a parentheses 3. So there are 3 of these. Okay, so NO3 3 times. Now, if you guys take a look at this molecule, there is 1 Sb, right? So this Sb has to balance out all 3 of these nitrates right here. Okay, which means since this is -1, -2, -3, Sb has to be +3. Okay. Okay, and then from there, we're ready to write the equation. Okay. All right, so like I said, the molecule I'm giving you here, this is what we end up with. This is what we get at the end. So let's write down our chemical equation. So we start with 1 Sb3+. We're going to write down 1 Sb3+. We're combining that with 3 nitrates. So we're going to write 3 nitrates. We're going to draw an arrow. And the chemical that we make is this thing right here. God bless you. Sb parentheses NO3. And this right here at the bottom is going to be our answer. Okay, so a little bit different, but it's pretty much the same thing. This time I'm giving you the chemical that you end up with. You just need to figure out, God bless you, what it's made out of. Okay, just break it up and then finish up the equation from there. All right, so let me give you guys about 2 minutes. See if you guys can do number 4 with the person next to you. What you'll have to do is you need to go to the chart, the polyatomic chart, to figure out what SO4 is, and that'll let you guys finish up the rest of the equation. We'll go over that together in 2-3 minutes, and then I'll get you guys started on your assignment, okay? So try that out. Okay, so let's start by breaking down this chemical right here. Hopefully you guys can see that you have SO4, and if you look at the SO4 on the polyatomic chart, it's sulfate, which is SO4 2 minus. Okay, so we're just going to copy that down. SO4 2 minus. So this chemical has SO4. We got 3 of them, right? So SO4 2 minus 3 times. Now, we have Al, and we have 2 of them. So we have Al twice. Okay, now, you can do the math and figure out what Al is, or you can go to the periodic table, and you guys should be able to identify that Al, the MCI for Al is positive 3, okay? So Al is going to be positive 3. So you could either find this on the periodic table, or you can just do the math. SO4, this is negative 6 added together. So it has to be positive 6 to balance that out, okay? All right, now we're ready to write the equation. So we have 2 Al3 pluses, so we got 2 Al3 plus. We're going to combine that with 3 SO4 2 minus. You're going to be making 1 molecule, and the molecule that you make is what's given to you, Al2 SO4 3. Okay. And that's it. That's how you find the ionic compound chemical equations backwards and forwards. And that's pretty much what your assignment is going to be.